morning, dear students. In the last video, we have learned about Cori cycle and muscle twitch. In this video, we will start with muscle tonus. What is muscle tonus? Muscle tonus is simply the partially contracted state of some muscle fibers or cell. Muscle fibers, it is otherwise called a muscle cell. Muscle cell in all skeletal muscle of a person to maintain his posture at rest. That is important. So, during the time of rest, for maintaining the posture, in all skeletal muscles, a few muscle fibers are in a partially contracted state. That partially contracted state is maintained to achieve the posture. Okay, clear? Then how that a few muscle fibers, they continually remain in partially contracted state through stimulation of a few motor unit. They are constantly get stimulated. Motor unit, I think that term is clear to you. Motor unit means a single motor neuron. Motor neuron will be there. Oh, what a type of neuron this one. Anyway, and its axon branches and will supply a set of muscle fibers. And the entire unit will form the motor unit. So, a few motor units, they keep on constant activation to keep some muscle fibers in all skeletal muscles in a partially contracted state to maintain the posture of that person while at rest. Okay, next is about fatigue. What is fatigue? It is a state or condition of the muscle, and during that state, that muscle will not able to respond to a stimulus to produce a powerful contraction. Okay, so there are some other conditions also there to cause this fatigue. Look to this graph. We know that this is a graph for simple muscle twitch. And we have learned that three periods are there: latent period, contraction period, and relaxation period. And the relaxation period is the lengthier one. And whenever a muscle receives repeated stimulus during its relaxation period, then that time it cannot give out powerful contraction. Only weaker contraction and finally stop to respond. Okay. So that is what. During its relaxation time, it is getting that stimulus. So that is why it cannot give up powerful contraction. That is one thing during the relaxation period. Next thing is that these stimulations are not so closer. There is enough time interval between these stimulations. If it is so closer, then that may result in a tetany condition. As it is not that much closer, tetany also will not occur. And the muscle will come to the fatigue condition. Then what are the reasons for a muscle to come to this fatigue condition? Three reasons are there. One, we already learned that in the former videos, while during vigorous exercise, as the muscle depends on anaerobic glycolysis or anaerobic metabolism, that will lead to the accumulation of lactic acid. And that is one reason for getting fatigue. Another reason is the reduction in the release of calcium that is stored in the sarcoplasmic reticulum. We know that it is the storehouse. So that reduction also is one reason. And the third reason is the fall in ATP level. All these things will lead to a muscle to reach the fatigue state. Okay. Next is about isometric and isotonic contraction. What is the difference between these two types of contraction? First, we can take the case of isometric contraction. Look to that word, isometric means same metrics, same dimension during contraction. That means during that type of contraction, muscle is not shortening, but it develops tension. So tension is there, but it is not shortening. That type of contraction is called the isometric contraction. For example, whenever we hold some weight, that time in our muscle, tension is developing, but it is not shortening. That is one example. I will show you one more image. In this image, we can see that this girl is carrying a weight and in her muscle, that tension is developing, but it is not shortening during that contraction. And also, in this type of contraction, there is no movement. There is no movement. So, the muscle is not shortening as well as no movement is happening. In all instances, we can't tell there is no movement. Anyway, important pointing is muscle will not shorten during isometric contraction. Okay. Next, we can see about isotonic contraction. Isotonic contraction here, during that type of contraction, muscle will shorten and lengthen. Two phases are there. The shortening phase is called concentric phase or concentric type of contraction, and lengthening phase is called eccentric. Okay, so here during that contraction, muscle will shorten as well as lengthen. And also there surely there will be some movement. Example, lifting some weight, or for as a common example, we can just imagine we are taking some water in a glass and bringing that glass with water towards our lips. That time, that muscle there is contracting. So that's one our daily life example. And lifting a weight also can is a very common example. Anyway, I am going to show you a small animation to understand better about isotonic contraction. Here, the muscle is shortening, then lengthening. Shortening is called concentric contraction. Lengthening is eccentric contraction. Movement also is there. Okay. I think it is very, very clear to you. Next, we are going to understand about oxygen depth. It is a type of depth, depthing of oxygen. When it happens, we need to understand. In the body of a normal person, there is always a storage of 2 liters of oxygen. And in which all places this oxygen is storing? Some amount of oxygen is stored in lungs, and some amount of oxygen is dissolved in his body fluids, and some is bound with hemoglobin and myoglobin as oxyhemoglobin and oxymyoglobin, and some oxygen is bound with the muscle fibers. And all together, this will constitute 2 liters of oxygen. This is the stored amount of oxygen in the body of an organism. It is a reserve. Okay. And when he started to do some vigorous exercise, this 2 liter stored oxygen get exhausted. Then the body will do what? It depends on some anaerobic mechanism to meet the energy requirements. So it depends anaerobic metabolism. We know that anaerobic metabolism generates lactic acid, and as the lactic acid concentration steepens in body, it leads to fatigue, and in that condition, that man's muscles are in a state called oxygen depth. Why it is called oxygen depth? Because that muscles already have used up the stored amount of 2 liters. Now the muscles are in a depth and also a huge load of lactic acid in his body. Then how can resolve this oxygen depth? After finishing that exercise, that person need to breathe fast. He need to over breathe to take additional extra amount of oxygen to compensate that oxygen debt that happened during that vigorous exercise. And what are all the exact purpose of that additionally taken in oxygen? Which for which all purposes, which all process it is using, that we need to understand. Okay. That additionally breathed in oxygen, it accounts around 11 liters of oxygen, and that amount constitutes the oxygen depth value. And of this 11 liters of oxygen, 9 liters are using up for the breaking down or conversion of the lactic acid formed during that vigorous exercise to glucose, and the other process that is taking apart from this 9 liters of oxygen is the formation of phosphocreatine. From where? From creatine and phosphate. Clear? So using creatine and phosphate again need to regenerate phosphocreatine. So that process also takes a portion among this 9 liters of oxygen. Then the balance 2 liters is sharing among these three processes for the conversion of ADP to ATP and to bring back the normal oxygen level in lungs, and also to bring back the normal amount of oxyhemoglobin and oxymyoglobin. So all these processes are part of compensation of oxygen debt. Okay, next we need to learn a definition for oxygen debt. It is the additional amount of oxygen. It is the additional amount of oxygen consumed after excessive exercise. And that consumed amount of oxygen is required for the aerobic conversion of anaerobic product like lactate. I think it is clear. So, oxygen depth is the additional amount of oxygen consumed after excessive exercise. For what? For the aerobic conversion of anaerobic products. That is the definition. Okay, is it clear? Next thing that we need to learn is about rigor mortis. What is rigor? Rigor, rigidity. It is a state of rigidity of muscles. Why? Due to the complete deprivation of ATP and phosphocreatine, which are the sources for muscle contraction. So, as these sources, when get exhausted completely, then muscles will reach a rigid condition, and that state is called rigor. Then what is rigor mortis? Rigor mortis means when that rigor, if it happens after death, then it is called rigor mortis. Then what is the physiology of this rigor mortis? How it happens? Then we need to brush up some points from our memory. And that's it. In almost all compartments in our body, that is in different cells and inside the cell, different organelles present. All those structures we can consider as compartments of our body. And across the membranes of all those compartments, there exists some gradient, ion gradient. And that gradient, we have learned that it is maintained with the help of some pump, and these pumps are working with the help of ATP. So, keep these things in your mind. Then come to the point. After death, in the place of this ionic gradient, ionic equilibrium happens across all the compartments. Why? Because there is no ATP to build up that gradient. Then, as there is no ATP, the gradient is not possible to create. So that is why ionic equilibrium happens across all compartments of it. And the same thing happens with respect to the sarcoplasmic reticulum. We know that sarcoplasmic reticulum is the storehouse of calcium in the muscles, and the calcium stores, it leaks out to come to equilibrium. As it leaks out, it can go and bind with the troponin and bring about uncontrolled contractile activity. And as that uncontrolled contractile activity starts there, that will lead to the exhaustion, complete deprivation of ATP store. As there is no ATP, it is not possible to release the cross-linking between thick and thin filaments. And that highly cross-linked state is called rigor mortis, stiffness. I think it is clear. Then what about the duration? Duration of the rigor mortis vary with the temperature of that environment. And usually that rigor mortis will start from 10 minutes after the death to several hours. So, by checking the rigor mortis, its strength, its extent, we can predict up to certain extent that when that death happens. And maximum stiffness will reach around 12 to 24 hours. First, our facial muscles get affected. After that, it will spread to the remaining parts of our body. And regarding the joint, it can remain stiff for 1 to 3 days. And after all this duration, then will start the general tissue decay. How it happens? Because of the leakage of lysosomal enzymes. As this lysosomal enzymes leaks out, it will resolve, it separates the cross-link between thick and thin filament, and that rigidity will completely. Okay, I hope that it is very clear to you. And by this way, finish the muscle physiology chapter and also today's section. Thank you.
I'm an icon, man. And my girl about a 10. I should fuck her in the Benz.